Assignment 1, Mathematical Exploration, Math Script, Problem 3, Tiling Patterns, Miss Sienna Breen. My name is Sienna Breen. My student number is 3222542, and I solemnly declare that this presentation is entirely my own work. This presentation has been structured to be delivered to Year 5-6 students. In today's lesson, we are going to identify how many rectangles of varying shape and size can be formed from a given number of squares. Whilst this exercise can be a fun, hands-on experience, it will also exhibit important mathematical concepts, including prediction, multiplication, factorization, and pattern recognition. Okay, let's start by trying to see how many rectangles we can make by arranging 12 separate square blocks in different patterns. In this case, we are using dice. It will be easier if we adopt a consistent process, so let's start by making a rectangle of 1 row and 12 columns. This is clearly a rectangular shape using 12 dice, so we now need to record the shape of this rectangle as 1 by 12. Logically, we would then see if we can construct a rectangular shape of 2 rows using 12 dice. This is easily achievable by distributing the 12 dice evenly along 2 rows. The shape of this rectangle is then recorded as 2 by 6. If we continue this process, we find that distributing 12 dice along 3 rows also provides a rectangular shape, which is recorded as 3 by 4. A rectangle constructed of 4 rows and 3 columns is of the same shape and size as a rectangle of 3 rows and 4 columns, so cannot be considered as being a different shape. In continuing our process, we quickly identify that a rectangle of 5 rows cannot be made from 12 dice, as there is only 1 extra block. As we attempt to construct rectangles of an increasing number of rows, we find that we are either unable to construct a rectangle or we have previously created a rectangle of the same shape and size. The process we have applied confirms that only 3 different forms of rectangle may be constructed from 12 individual dice. The shape of these rectangles can then be written as 1 by 12, 2 by 6, 3 by 4. But what if we were then asked to see how many rectangles we could construct with 20 dice? More dice, more rectangles would seem to be a reasonable assumption, though let's see if this holds true. If we apply the same process previously used, we find we are able to construct 3 differently shaped rectangles, 1 by 20, 2 times 10, and 4 by 5. Somewhat surprisingly, the experiment using 20 dice has not delivered more rectangles. What if we have even more dice, say 100 or 500? We could continue to use our existing method to identify how many rectangles could be formed, but this would become an increasingly long process and require hundreds of dice. What if there was an easier way? Thankfully, there is. All of the numbers we have recorded are factors of the total number of dice used, just as the image below shows. Factors are the numbers you can multiply together to get another number. Factor pairs. In both experiments, the shape of the rectangle as written are also factor pairs of the total number of dice. 1 by 12 equals 12, 2 by 6 equals 12, 3 by 4 equals 12, 1 by 20 equals 20, 2 by 10 equals 20, 4 by 5 equals 20. Factor pairs are simply 2 numbers multiplied together that then equal another number, called the product. If we apply the factor relationship using 100 dice, we can identify 5 separate factor pairs: 1 by 100, 2 by 50, 4 by 25, 5 by 20, and 10 by 10. We could very quickly state that this is therefore possible to construct 5 different rectangles using 100 dice, though this would not be true. A shape of 10 rows and 10 columns is a square, not a rectangle, and cannot be counted. Our experiment using 100 dice has confirmed we are able to construct 4 different size and shape rectangles. Having completed this lesson, you should now be able to identify and calculate how many rectangles of varying shape and size can be formed from any given number of squares. We have also discussed and developed a greater understanding of general mathematical concepts including prediction, multiplication, factorization, and pattern recognition. These skills are perhaps some of the simplest mathematical concepts, though certainly also some of the most important.